Hello, this is our second video from Calculus 1 over section 4.2, our second video of examples from 4.2 where we're looking for finding extreme values of a function on an interval. So I've got three examples for us to work. Before we launch into it, let me just remind you of the process. First, we're going to find the critical points. So this is building on what we did in the previous video. And then second, we're going to evaluate the function at all critical points and the endpoints of the interval. And the largest of those outputs is the absolute max. And the smallest output is our absolute min. So let's apply that to this polynomial y equals x cubed minus 6x squared plus 8 on the interval from 1 to 6. So first, we want to find the critical points. So I'll calculate the derivative. 3x squared minus 12x. I will solve y prime equals 0. And I'll notice that this factors as 3x times x minus 4. I can pull the common x out. And so x equals 0 and x equal 4. Those are my critical points. And so that takes care of step 1. Step 2 then is to build a table where we look at the x-coordinates and the y-coordinates. Now, one thing I want to notice about this particular example is that one of my critical points does not live on the interval of interest. So we're interested in the interval from 1 to 6, and so I don't have to worry about x equals 0 since that is not on my interval. If my interval had been from, say, negative 1 to 6, then I would have included both critical points in my examination here. But as it is, I list the endpoints and the critical points, and my style is just to write them in increasing order. And so y of 1 here is 3. Y of 4 is going to be 64. 4 squared is 16. 6 times 16 is 96, so subtracting 96 plus 8, and that's going to give me negative 24. And then y of 6, 6 cubed is 216. 6 times 36 is also 216, and that gives me 8. And so now what I do is I just look at my outputs, and I pick out the largest and the smallest. So this is the smallest one, so this is my absolute min. And this is my largest one, and so it's my absolute max. So let's go ahead and report back. So the absolute max on the interval from 1 to 6 is y of 6 equals 8, and the absolute min on this interval is y of 4 equals negative 24. And notice what I'm doing here with this reporting back. I'm providing the outputs, but I'm also providing the inputs. And that's an important thing we want to be able to do, generally speaking. We not only want to say what the max and min values are, but we also want to indicate where they're located. So I would say that there's a maximum of 8 at 6 and a minimum of negative 24 at 4. Notice the use of prepositions here. Of will tell me what the y-coordinate is. At will tell me about the x-coordinate. My next example is a trig function, y equals cosine theta plus sine theta, and we want to look over the interval from 0 to 2 pi. So step 1, critical points. y prime is minus sine theta plus cosine theta. Those are defined on the entire interval, so I want to solve y prime equal to 0. And I don't have a lot of algebra I can do here, but I need to kind of reason through what I remember about trig functions. And so if I add sine theta to both sides, I get cosine theta equals sine theta, which means I'm looking for angles in either the first or third quadrant, because that's where the sines and cosines are equal. Sine and cosine are both positive in the first quadrant. They're both negative in the third quadrant. And so let me think about the angle in the first quadrant, where these two are equal. If I think about it a little bit, I might remember that sine of pi over 4 is the square root of 2 over 2, and cosine of pi over 4 is the square root of 2 over 2. And so in quadrant 1, I get theta equals pi over 4, and that means that if I go to quadrant 3, they're both going to be negative square root of 2 over 2 at 5 pi over 4. So this is where we really are needing to be on top of our trig knowledge to answer a question like this. So I found my critical points, pi over 4 and 5 pi over 4. Those are both on the interval from 0 to 2 pi. And so my second step is to create my table. And so this time I've got 2 endpoints plus 2 critical points. And so y of 0, cosine of 0 is 1, sine of 0 is 0. And we've commented that sine of pi, or cosine of pi over 4 is the square root of 2 over 2, as is the sine of pi over 4. And when I add those together, I get the square root of 2. And at 5 pi over 4, I'm going to get the opposites. They're both negative square root of 2 over 2. When I add those together, I get negative square root of 2. And then finally, y of 2 pi is going to give me 1 plus 0, or 1 again. So I need to remember that the square root of 2 is about 1.414, and so that's going to be bigger than 1, so this is my absolute max. And as the only negative number amongst my options, this is going to be the absolute min. And so I would report back and say that the absolute max of y is y of pi over 4 equals the square root of 2, and the absolute min of y is y of 5 pi over 4 equals negative square root of 2. My third example involves an exponential function. We've got a product again. So I'm going to find my critical points. Y prime is going to be 1 times e to the minus x plus x times, and then I use the chain rule to get the derivative of e to the minus x. That's going to be e to the minus x times negative 1. And I can tidy this up a little bit this way. And then if you notice, I've got a common factor of e to the minus x. And so I could rewrite this as e to the minus x times 1 minus x. And so this is defined everywhere. So I want to solve y prime equals 0. So I've got it in factored form already. And what I want to remember is that this is always positive. And so there are no solutions from this. And so therefore, my only critical point is x equals 1. And I create my table. My endpoints are 0 and 2. My only critical point is 1. Y of 0 is going to be equal to simply 0. 0 times 1. Y of 1 is going to be 1 times e to the negative 1, or e to the negative 1. And then y of 2 is going to be 2e to the negative 2. Now to figure out the max and mins, I again need to think about decimal approximations. We said in the previous video that e to the minus 1 is about 0.368, and if you plug into your calculator, 2e to the negative 2 is about 0.271. And so this is my max, and 0 is going to be my min. So the absolute max of this function is y of 1 equals 1 over e, and the absolute min on this interval is y of 0 equals 0.